Hello up there. I'm trying a new arrangement with my camera and the old tripod. But we're talking properties of exponents, and we're going to talk about them today in terms of triangles. And there's no triangles on the board because we're going to talk about it in terms of triangle area. So first, let's remember how we get triangle area with a rectangle. Southam, that's a rectangle. That's not a triangle. Okay, fair enough. But here's it's a rectangle. Could be you could have a square, anything with a bunch of right angles in it. But we get the area formula for a triangle by taking our rectangle, which the area is base times base times base times height, and then we cut it in half like so. So that's where it comes from. So the area of a triangle is base times height divided by 2. So that's what we get here. So the area of a triangle equals base times height divided by 2. There you go. So we're going to make a triangle, and I'm going to put it over here. And I'm going to make it with a base of 20 and a height of 81 centimeters. We're not talking just centimeters today. So let's see what we can do. Uh-oh. Wait. That's not going to be enough room. Oh. There's our triangle. But some of them, it's all tilted. That's okay. Triangles are tilted in the world. I should clarify this. You have to have a right angle between the base and the height. So the right angle is here, and I designed it to be that way. So let's see, I said this has a length of 20 centimeters, the base here. The height I said is 81. So there we go, the whole height here is 81. So if we're talking the area of this triangle, the area, I'm going to put this little subscript 1 to say this is the first area. It doesn't mean it doesn't do anything, it's just like that's the first triangle. Base is 20, height of 81 all over 2, which is going to give us, let's see, 20 divided by 2 is 10 times 81, so 810 centimeters squared. So what we're going to do, we're talking exponents, so we're going to take this into thirds. We're going to take the height, and we're going to cut it into thirds, and we're going to take 1/3 of the height. So 81 divided by 3 ends up being 27. So let's do that. 27. And then the other third would be 54. So 1/3 of 81 is 27. I'm going to throw a 27 right here. And I'm going to move the 81 up here to signify like this is the 81 length. Here's the 27 centimeter length. So there's our triangle here. There we go. So the base is still 20, but the height has changed to 27 centimeters. So the second area, I'm going to run out of room. I better make this smaller. The second triangle area is 20 times 27 over 2, which that's going to give us, let's see, that's going to be 10 times 27, so 270 centimeters squared. Let's take 1/3 of that. We're going to, 1/3 of 27 is going to be 9. 9 puts us right here. I put the 18 mark to show that's where we're cutting this length into thirds. So here's the other one, 9 right here. Boy, that sure is shrinking pretty quickly, huh? So the area of this one is 20 centimeters for the base, 9 centimeters for the height. 20 divided by 2 is 10. 10 times 9 is 90 centimeters squared. Let's keep going. A third of 9 is 3.
Oh boy, look at that.
Look at that. So that's 3 centimeters. Really getting short really quick. So the fourth area is 20 centimeters times 3 centimeters over 2. 20 over 2 is 10 times 3 is 30 centimeters squared. Let's keep going. A third of 3 is 1. I don't know why I flipped that around. Oi. Yes. This is. All right. Look at that. Look at that thing. There it is. 1 right there. Bink. The fifth area is the base is 20 centimeters times 1 centimeter over 2. Let's see. 20 over 2 is 10 times 1. You get 10 centimeters squared. Well, let's keep going. Obviously, we have some limitations here, so what should we do? My Expo pen is getting pretty. It's too thick for this type of thing. So you know, I'm gonna do a zoom in image. I'm gonna go like this. Whoop, do that little zoom thing. I'm gonna redraw the scaled triangle here with a base of 20 and a height of 1. I'm gonna try this out with. Let's see. How should I do this? Can I do that? You know what? I can. I totally can. I'm gonna scale this up by 3. But we're still going to call the lengths 20 and 1. This is the scaled drawing. So this is these are actual measurements, 20 centimeters, 1 centimeter. This is going to represent the 20 centimeters, but it's actually 60. I took this times 3, so then this is no longer 1, it's actually 3.
I think this is where I'm gonna call it after
this. So to give you some perspective, this is the right angle right here. And then it's going up like this. And then the angle, it's like coming up like that. So this little triangle here is right, that teeny little one right there. But we're still taking thirds, so this is 1. And then we're going to take a third of that. So which would be a third of a centimeter, but for the scale drawing, it's actually going to be 1. So that's roughly there. So it's still going to be rather thin. That's okay. All right, that'll work. I think we're done. I think we're zoomed in as much as we can. And this is a third. So the area of the sixth triangle is 20, the base of 20, a height of a third, all over 2. So let's just play with this still. You can have a fraction in the numerator, that's fine. 20 over 2 is 10. 10 times a third is 10 thirds. There we go. All right, so there we go. We've done some, we had some triangle. We kept taking the height and taking thirds of the height, and then we even scaled that. We zoomed in and then scaled down even more. And so we can see how these areas are decreasing. But the purpose is to explore properties of exponents. So we're going to look at this here, but we're just going to look at one value in the area of a triangle, specifically the one that's changing, which is this value, the height. We're only going to look at the height for the next part. So I'm going to go ahead and get this board cleaned up, and we're going to explore that. Let's see. I always forget the spot. Ah, all right, there it is. So cleaned up the board, and I've made a table here that has the height, and I added this column called number of thirdings. How many times do we take a third? So we started with 0. We didn't take any of them. And then by the first one, we got to 27. And the second one took us down to 9. And the third one took us to 3. The fourth one took us to 1. All right. And then let's see. Then the fifth one took us to a third. We could keep going, and this number would keep this would keep going down. But we're looking at the properties of exponents. So we're looking at how does this all stuff relate to properties of exponents. So let's go ahead and play around with that. So we had, this is our first height, which is 81. So let's say we wanted to figure out the height after we took 3 thirdings. So the height is 81, and after 3 thirdings, let's see, that means we divided by 3 1, 2, 3 times. So we divided by 3, but this is where the properties of exponents come in. 3 to the third. We want to take 81 divided by 3 to the third, and that's going to take us to the height. After 3 thirdings, what's our height going to be? What is our height going to be? And this ends up being 3, but we're exploring exponents. So let's play with that. So let's see, 81 in terms of threes is 3 to the 4th. And we're dividing by 3 to the 3rd. So what we have, we see 1 3 there. So that's exactly what we're left with, is 3. Now, why is that the case? 3 to the 4th is the same thing as, it means 4 3s multiplied together. And we're dividing by 3 to the 3rd. So we're dividing here. So 3 divided by 3 is 1, 1, 1, and then we're left with a single 3 right there, 3 to the 1st. So what if we wanted to figure out how do we go from 81 to a third using this method? Let's play around with that. Oh, it pains me to erase this, but I will. So, let me write this out. This was after 3 thirdings. And then over here we'll do after 5. It's weird to write thirding, so I'm not going to do it anymore. Oh, I will, just for consistency. So we had 81 divided by 5. So that means it's 3 to the 5th, because we're dividing by 3 5 times, which is exactly what this is saying. And we should get a third, so how do we get that using exponents? Well, 81 is 3 to the 4th. And we have 3 to the 5th in the denominator. If we were to write this out, it'd be 3 times 3 times 3 times 3 all over 3 times 3 times 3. And I hope you're starting to see why these exponents can be useful, so we don't have to write out all this stuff. And now we're going to just start dividing out. So 3 over 3 is 1. 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 So in the numerator, all we're left with is 1. And in the denominator, we have a single 3. So 3 to the 1st, or just 3. And so there's our value. That was the one. It looked like a comma or an apostrophe, so I'll just leave it alone. So a third. So that's what we did with using exponents. So the general rule for exponents, it's called the quotient law, the quotient law of exponents. Or rule. I used rule the other day, so we'll use that. Actually, let's do the specific thing here first, then we'll do the rule. 3, let's see essentially what we had. It was 4 3s and 5 in the denominator. So this is what we're doing. 3 to the 4 over 3 to the 5 is actually 3 to the 4 minus 5, all in the exponent. And this gives us 3 to the negative 1. And we've talked before about how negative exponents mean you take the reciprocal. So this means 1 over 3. So the quotient rule of exponents is what we have right here. If you have some base, we'll call it b, to the nth power divided by b to the m, this is the same as b to the n minus m. And that's the quotient rule of exponents, which we got to by playing around with the area of triangles. There you go. Thanks. Bye.